Hello everybody, I hope that you are enjoying your day so far. Today we are going to be working on solving quadratic equations by completing the square. So just do now here, hopefully you were able to print out a copy of the notes. If not, you might want to just jot these down, press the pause button, and then once you play it, you'll see the answers pop up. So I'll give you a chance to do that for the do now. Alright, and we'll see that we have our answers here. When we factor these out, notice that 1, 2, and 4 were originally perfect square trinomials. So then they factored out to become this, which is important to notice because that's what we're going to be using today. We're going to want to get a perfect square trinomial so that we can write it like this. So we'll see why that's important in just a little bit. And this was turned into a difference of squares. Okay, so what we're going to do today is completing the square. So the important thing to note out of this core concept is that we need to have an expression in the form x squared plus bx. You'll notice there's no a in front of the x squared. Usually it's ax squared plus bx plus c. But in this case, we need the a value to always be 1. So if the a value is not 1, we have to divide it by whatever the a value is to make the a value into 1. So that's why they don't put an a value here, because it always has to be 1 when you want to complete the square. You'll also notice that there's no c value. The c value is something that we're going to add to both sides. And again, we'll see that in just a second. But from this core concept, what you really need to note is that a is always 1, and you just have x squared plus a bx, and that's it. And that's what you need to complete the square. Step 1 says the first thing we're going to do is find 1/2 of b, which is the coefficient of x. We're going to square that, and then we're going to add that to the expression. And then we're going to factor resulting expression as a square binomial. So we'll see how that looks right now. So for a, we have x squared plus 6x. Our b value is 6. So if I take half of 6, well, that would give me 3, right? So half of 6 would be 3. So that was the first step. Now I'm going to square this, and that gives me 9. So half of b squared would be 9. So now I'm going to add 9 to this. So I have x squared plus 6x plus 9. Now the last step is to factor it. So if I want to factor this, your a value is 1. What two values multiply to 9 and add to 6? Well, 3 and 3. So that's because this is a perfect square trinomial. So I can rewrite it as x plus 3 squared. So we've completed the square for x squared plus 6x. Now we'll do it over here. We have x squared minus 9x. So our b value now is negative 9. So we're going to do negative 9 divided by 2 squared. Now, you could write negative 4.5 squared, which is totally fine. But the other option here is just square both the top and the bottom. So if you square negative 9, you get positive 81. And if you square the bottom, you get 4. So 81 over 4 is half of b squared. So we'll just add that to it, and that'll complete our square. So x squared minus 9x equals, plus 81 over 4. So now if we want to factor this, you might be saying to yourself, well, how in the world am I going to know what two numbers multiply to 81 over 4 and add to negative 9? Well, it's simple. This is what multiplies to a positive 81 over 4. And then if you add it, it adds to negative 9. So you just have negative 9 over 2. So to factor it, you have x minus 9 over 2 squared. And that's not a coincidence. That will happen every time. You'll notice if we go back to this one here, when we factored it, this value here was the value when we divided b by 2. So it is important to note that you have to add 9 to both sides later on, but for right now, when you're factoring it, you're going to get x plus whatever half of b is. in your squared, which is going to be your final factored form. All right, so why don't you go ahead to examples 1, 2, and 3. Pause the video for a second, try them out on your own, and try to complete the square for the expression, and then factor the trinomial. When you're all set, press the play button again, and check your answers. All right, so now we'll have our answers up on the screen here. If you want to pause it to take a deeper look, feel free to do so. Just note, you might be thinking to yourself, is this important, this x squared plus 10x plus 25? Is this step important since you can just get x plus 5 squared from this value here? And the answer is yes, because this is completing the square. So you'll notice there's 2 steps: complete the square for each expression, which is this, then factor the trinomial, which is this. So make sure you're reading the directions so you know what you have to do for that problem. So here's your answers. Again, pause the screen if you'd like it. Otherwise, we are going to move forward. So for this example, we'll see why we can use this completing the square to solve an equation. So for these examples before, notice that this expression and this expression are not equivalent. They're not the same thing, right? We were just practicing this so we can see what we have to do when we have something like this. For an equation, whatever you do to one side of an equation, you have to do the other side of the equation to keep it to be the same equation. So we're going to complete the square now. So we're going to take half of b, which is half of negative 16, which gives us negative 8, and we're going to square. So negative 8 squared is positive 64. So I have to add 64 to both sides now. So I'm going to add 64 to the left-hand side, which will give me x squared minus 16x plus 64. And then I'm also going to have to add 64 to negative 15. So negative 15 plus 64 is 49. So that's how I get 49. Is again because I added 64 to negative 15. I added 64 to the left-hand side, I added 64 to the right-hand side. So this is what we have now. At this point, we can now factor this side. So we've completed the square on this side. Now we can factor this side. This is a perfect square trinomial. This is x minus 8 squared. And that equals 49. So now from here, we can solve this by using square roots, the same thing that we did the other day. If you take the square root of both sides, take the square root of this side, you're going to get the positive and negative square root of 49. Squeeze that in there. And so now I'm just going to continue up here. I'll have x minus 8 equals 7. And x minus 8 equals negative 7. And I solve both parts. X equals 15. And x equals 1. Remember, these solutions are still the x-intercepts. They're still the zeros, the roots, the x-intercepts, all those things. It's x equals 15 and x equals 1. If we wound up getting no solution, it would mean that there's no x-intercepts for that quadratic. All right, so take a look. And again, if at any point you're having questions on these things, make sure you're putting them in the Google Doc that's attached to Google Classroom. All right, and if you want to challenge yourself a little bit, pause the video here and try to answer this one on your own. When you're ready, play the video and we'll go along with how it looks. So if you're ready to go on, so the area of a patio is 216 square feet. Here's the patio, right? So we have x plus 6. This is a rectangle. So if we're writing an equation that represents the area of the patio, well, we would have x times x plus 6. And that's going to equal 216. Now remember, this is the start, but this is not the final answer here. So what we're going to want to do now is simplify this out, right? So we're going to have to do x squared plus 6x equals 216. Alright, so I've multiplied that out, and here's my final answer. So this is your final answer, this x squared plus 6x equals 216, because it's simplified. You don't want to leave something not simplified, even though I agree this is an equation that does represent the area of the patio. This would be the best answer to get full credit for that type of problem. Now it says find the dimensions of the patio by completing the square. So we have to complete the square for this. So we're going to take half of b, square it, and add it to both sides. So half of 6 would be 3, and 3 squared would be 9. So I'm going to add 9 to both sides. So if you're confused how we got here again, I took half of b, so I took half of this, which gave me 3. I squared it, that gave me 9. I added that to both sides, and now we have this, x squared plus 6x plus 9 equals 225. So now we'll notice that we have ourselves a perfect square on the left-hand side, which would become x plus 3 squared equals 225. And if you take the square root of both sides of that, you get the positive and negative square root of 225. So x plus 3 equals 15. And x plus 3 equals negative 15. X isn't going to be a negative because x is representing our side length here. So I know right away that this is not going to be an answer. So I'm just going to work with this one. Our x equals 12. So if x equals 12, the direction said find the dimensions of the patio. So I would say the width is 12 and the length is 18, because 12 here and 12 plus 6 is 18. So it would be a 12 by 18 patio. So that is how to solve by completing the square when the a value is 1 and you just have a b value on that side. So I'm just going to give you guys some practice examples that look like this for today, and then tomorrow we'll kind of add a few more steps to it. So good luck today, and if you have any questions, please put them on the Google Doc. If my responses aren't enough, then make sure you reach out to me and we'll set up a meeting. All right, have fun today, guys. Thanks. Bye.